This is Grasshopper tutorial number 1. We're going to cover the interface of the Grasshopper software plugin. We're going to talk about the difference between implicit and explicit history in Rhino and Grasshopper, and look at a few basics that we'll need to know moving forward in the program. So firstly, let's start in Rhino and talk a little bit about something called implicit history, which is the precursor to Grasshopper. So in Rhino, there's a button down here on the bottom called Record History, and we haven't really talked about this yet. But as an example, let's look at what happens when we loft two lines together. So I'm just drawing two curves, and then I'm going to move one vertically, and I'm going to loft the two curves together. The resulting surface has no connection to the curves that it was created from, other than the fact that its geometry is based on the curves. If I select the curve, turn on its control points, and move one of those points around, the surface doesn't update. There's no history recorded between the two. Obviously, as architects, it's helpful for us to be able to have these kind of parametric relationships between things. So if we want to define kind of a base structure or base geometry, and then have resulting things that we build up off of it have a relationship back to it and allow for things to constantly update rather than having to constantly be rebuilt. So Rhino started to address this issue by something called excuse me, implicit history, which is defined down here by the Record History button. And what it does, if I turn this on, so if I just click on it and make it bold, and loft the surface again. So I'm selecting the same two lines and I'm lofting them, but Record History is on, it's bolded. I'm going to loft it the same way. And you can see that I have it set in here to not always record. So what that means is that the Record History option will stay on for one command and then automatically turn itself off. I definitely recommend this as the setting. If you accidentally have Always Record History on, you'll just run into major problems. So anyway, we have lofted this surface again using the Record History option. So to demonstrate the difference between this, I'm going to turn the control points back on for that curve, the top curve that the surface was based on, and you can see that now when I move the control points, the surface updates as well. The reason being that implicit in the history of this surface, so embedded into the structure of how it was made, is a connection back to these two original curves. And so Rhino will automatically now always update that surface if the curve updates. Note that if you move the surface, so I have just the surface selected, not the curves, and I move the surface, I'm going to get a warning that tells me that the history is now broken with this object. So if I say OK and now go back in and try to edit the curves, the relationship between the curves and the surfaces is broken. So I'm just going to undo back to where I have not lost my history, and show you that you can copy the surface if you want to break that connection but not lose the original surface. You can make a copy of it, which will break the history, but it will still allow for this original curve or original surface to be able to update based on the curve profiles. So if I update, this surface is now updating, this one is not. And this is a way that you can kind of rapidly cycle through iterations of something. Obviously we're just dealing with kind of abstract surfaces here, but you can imagine, oops, sorry, I'm upside down. You can imagine with different designs how you would start to be able to look at multiple iterations of something very quickly. Hopefully I didn't make anybody car sick. The other way that you can use this Record History option is through multiple layers of these histories that are recorded on top of each other. So for instance, if I turn the Record History button back on before I copy that surface, so I'm going to copy and make multiple copies of it, and then right click to end the command, and you can see that the Record History tab is not bolded, so it's off. And now when I turn on the control points for this same curve and move them around, you can see that all of the surfaces update. So you've basically kind of created an embedded parametric relationship between this original surface and the curves that it was created from and all of the copies from it. So there's one layer of recorded history in the structure, in the creation of the surface, and then there's a second layer of recorded history in the copies of that surface. So you can imagine that there's no way of tracking this, right? So you can imagine that it will start to become really confusing really quickly as to what is related to what history was first, what history was second. You can very quickly fall into situations where you have no idea what things are related to what and how they were structured and in what order the history was created. So one of the reasons that Rhino developed the plugin Grasshopper is to allow for this history to be made explicit or for it to be visible. And so Grasshopper is a parametric and history-based modeling plugin for Rhino. It's basically a graphical way of editing macros or small little computer programs or creating algorithms for your design. So I'm not going to go into the particulars of how you download and install Grasshopper. You can find that on the Grasshopper 3D, www.grasshopper3d.com website, where you can go in and download the latest build of Grasshopper. It's a free plugin. You just have to download it. And once you have it installed, you can type in Grasshopper into your command line in Rhino, and it will automatically pop up a window for the Grasshopper plugin. So let's see if we can get this to start up here. The first time you open it, it'll ask you to agree to certain terms and conditions. Just agree and hit yes. And so it brings up this little floating panel window that is basically Grasshopper. And so, as I said, it grew out of the implicit history in Rhino, where the kind of code was hidden and you didn't have any control over it. And it developed into this explicit version of history where you do have control over the relationships and how things are working. So I'll demonstrate this again. I'm going to make a copy with no recorded history on of these two original curves that we started with. So copy and move them over. And I'm going to do the same thing that I did here in terms of, I'm actually going to get rid of these guys because we were just talking about the surface at this point. I'm going to do the same thing that we did here in terms of creating a parametric relationship between these two curves in the lofted surface, but I'm going to do it this time through Grasshopper. So we'll go into the kind of layout in a second. I just want to give you an indication of what the program can do. So in Grasshopper, you have what's called a canvas, which is this area here, kind of under this kind of outline that gives you an edge, basically, to start from. And if you double-click in anywhere in the canvas, it'll pop up this floating command line. It does not have a command line like Rhino does at the top or bottom, or AutoCAD or any of those other programs, but if you double-click anywhere in the canvas, you'll be able to type in commands and it'll respond in the same way. So let's think for a second about how we made this original loft. It's pretty simple. It may seem pretty simple. What we need are two or more lines, and we need to tell Rhino that we want to loft those two lines together. So when we translate that kind of relationship or that definition into Grasshopper, we also need to represent two lines, and we need to represent the act of lofting them together. So let me show you here. I'm going to actually type in curve, and I'm going to have multiple options, but the one that I want is this curve parameter, which the parameters are, I'm just going to drop it into my canvas here, the curve. It looks like this. It comes from this geometry tab, and you can see that these are under the parameters, the geometry drop down under the parameters tab. These kind of black hexagons are parameters, which means that they are representations of geometry. So they're basically a little icon that stores information. So it'll store, a curve will store a curve, a surface will store a surface, and so on and so forth. So it basically is a holder of geometry, information, numbers, anything like that. So I need to have one or more curves, so I'm just going to Control-C, Control-V this so that I can have two of these, because in this case I have two curves. And then I also need something to tell it that I want to loft those two things together. So I'm going to type in loft, and I'll get this second little icon or this second little component that says loft on it. And all of these things have what are called handles on both sides. So they have a little input and they have a little output. And they'll be, in the case of the parameters, which are the geometries or the information, they basically just store things, so they don't really ask for different types of information. But things like lofting, or things that are actions, or in Grasshopper things that are called components like lofting, may have multiple inputs and outputs at times. If you hover over the letter of any of the inputs or outputs, a little tooltip will pop up and tell you what that means. So S in this case stands for section curves. So what are the curves that we want to loft together to create a surface? And also in the loft icon we have the loft options, which if you remember, I'm just going to quickly loft these guys in Rhino so you can see the loft options. So loft. So this kind of panel that comes up when you loft something in Rhino, these are the options that you can also plug into this component in Grasshopper. So I'm just going to cancel that and switch back into Grasshopper. So basically all I need to do to create a Grasshopper lofted surface is to connect by grabbing this handle and dragging it over into the section curves. I need to connect 2 or more curves to the loft. If I want to connect 2 things to one input, I need to hold down Shift. So if I am dragging this guy and holding down Shift, I can plug them both into the same input. Otherwise, if I do this without holding Shift, it's going to break the connection of the other wire. So these little connections between things are called wires. The last thing that I need to do to make this thing actually do anything is to tell it what 2 curves I want to loft together. So the way that I do that is by right-clicking and setting one curve. So I'm just right-clicking on the curve icon, or the curve parameter, and setting one curve. And it's going to switch me into Rhino, and up here in my command line it's asking me for the curve or edge to reference. So Rhino and Grasshopper talk back and forth to each other even though they look like separate entities. They're constantly kind of sharing information back and forth. So I'm going to do the same thing with the second curve. I'm going to set one curve here as well, and I'm going to pick the second curve. And you can see in Rhino now we have this red ghosted surface. And you also maybe noticed that the colors of these things changed in Grasshopper, and we'll talk about that in a second. But basically what we've done here is take 2 curves and loft them together. Pretty simple. But what it does allow us to do is to have the same operability in Rhino that we had using the record history or the implicit history, but now it's explicit, right? We know what 2 curves, we can go in and identify what 2 curves are lofted together. We could also copy them. So if I, well, let's skip that for now. It gets a little bit more complicated in Grasshopper, but you can do the same sequence of things, right? So you can control things order for, control the number of steps of things in order because you're mapping them out for yourself. Basically, you're making the history explicit rather than implicit. So just to continue demonstrating, I can update the curve control points, and the lofted surface will update as well. Okay, so that's the difference between the two. So you would use Grasshopper over record history pretty much in every circumstance. I can't think of one, unless it's one very simple kind of command that you're recording the history between things. I think Grasshopper is almost always the better option in terms of creating these parametric relationships between things and kind of maintaining them as you move through the project. Okay, so let's go a little bit more in detail into the kind of interface of Grasshopper. So Grasshopper is a parametric modeling plugin for Rhino. Parametric, as we know, is a relationship of fixed constants with variable values. So we have set up these guys, these 2 curves, and the loft as fixed constants, but we can plug in any number of curves into this. So for instance, I can create a much more kind of angular curve out of polylines, and right-click and set one curve, right-click and set one curve, and move one of those curves vertically, and have the same relationship created but between different curves. So that's the second kind of really powerful thing that Grasshopper allows you to do, is to, once you've created a so I'm just going to run back in here. I'm just going to switch back in here and reset these curves so that we can see our You can see our Grasshopper surface. Um, the powerful thing about Grasshopper is that once you've created a set of relationships between things, you basically have a library now of that sequence of actions that you took to make that, to define that design, define that process, define whatever it is that you've done. And you can use that over and over again on different types of projects, on different types of geometries. And so it's a really powerful way of working in terms of it may be a little bit of upfront work to build a definition. So this is considered a definition, a series of relationships between elements in Grasshopper. But it pays off down the road in terms of being able to maintain those relationships and not having to draw things over and over and over again. So Grasshopper, as we have seen, is kind of a separate window or interface within Rhino. Grasshopper files are .gxh files, and they are separate from Rhino files, which are .3dm files. So if you have a Grasshopper file and a Rhino file, you'll need to save them both separately. Typically, I'll save them as the same name, and because they'll have different file extensions, I'll be able to keep track of them that way. Another thing to note is that Grasshopper is unitless. It's basically diagrammatic, and so it deals with units. It deals with numbers. It'll count things, and it'll kind of keep track of things in that way. But it pulls its units from Rhino. So whatever Rhino file you're working on, the units that are set as the base in that file will be the base units for Grasshopper. So you work in this kind of canvas window that has a toolbar and a series of tabs that list categories of tools above it. So there's the parameters, which we've already mentioned, there's math, there's analysis, there's all sorts of different things up here, and we'll be getting more and more into them. But basically all of the different kind of parameters and components and actions in Grasshopper, almost all of them, are exactly the same types of things that you can do in Rhino. So if there's something that you know how to do in Rhino, you can most likely do the exact same thing in Grasshopper. You just have to kind of know what some of the different options are. So for instance, if we look at the different curve commands here, we'll see that we can create a curve from a center point and then a radius. We can create curves based on control points. We could go over here into the primitives and look at some of the different circle commands. So we remember from when we were in Rhino drawing circles in different ways, there were different ways of structuring them. Those same options for the most part are all also available in Grasshopper. So it's important to kind of have that basic understanding of how Rhino works to be able to come into Grasshopper, where it's a little bit not more confusing, but a little bit more important that you know the specificity of that type of information. So also on the top right of the Grasshopper window, we only have one file open at the moment, but if you have multiple files open, you can click up here on the top right and they'll be listed down here for you. So you can pull up you can be looking at multiple Grasshopper files within one session of Grasshopper, which is not the case in Rhino either. So let's talk for a second about colors in Grasshopper. So colors are codes that mean certain things in Grasshopper. If I were to go up here under a parameter and just grab any of these and drop them into my canvas, so I just grabbed a circle parameter and dropped it in here, that icon or that parameter is going to be orange, which means that it's missing information. So if I hover over it, I'll see that it's currently an empty circle parameter. It has nothing in it, and the orange is indicating kind of caution. It's telling you that, hey, there's something missing over here, you need to add kind of information to me. If I go over into Rhino and draw a circle, let's do that here so we're not overlapping, and I right click on my circle and set one circle, and I click on this guy, right click, set one circle, and actually I've just drawn another circle in Rhino. You can see that component, or I'm sorry, that parameter is now gray unless I have it selected. So it means that it's happy, everything's working. This light gray color is what you want all of your parameters and components to be ideally. If you highlight it or if you select it, it turns green, indicating that you have that item selected. And the corresponding object in Rhino, and I'm just going to delete this original circle that I had drawn. So this is the one that I drew when it asked me to set one circle in Grasshopper. The corresponding geometry between Rhino and Grasshopper will be the same color, right? So I select this, it turns green. I deselect it, it turns red. So any Grasshopper geometry in Rhino's viewport, in Rhino's kind of being visualized in Rhino, will be red. And we'll talk about that in a second as well. So orange means it needs information, light gray means it has information and everything is working. If you right-click on a component, typically, you can also do it for parameters. There are a couple other options in here under the name of the parameter or the component. The first one being preview. So if I click on this, you can see that my my surface in Rhino has disappeared. It's been hidden basically. So previewing, you can toggle that on and off, and we'll talk a little bit later about why that starts to become important. But when you have something previewed, you can see that the kind of component turns a slightly darker shade of gray. And that indicates to you that that geometry is turned off in Rhino. The second one in here, if you right-click, is called Enabled. And this is a slightly different version of the preview option. So preview hides geometry. Enable means it's gonna basically stop the definition at that point. So you can imagine that if we had two curves coming into this loft and then we were doing something else with this loft, if we continued building this definition, everything downstream or to the right of that disabled element will not function the same anymore because it's not receiving information. So Grasshopper, information in Grasshopper flows left to right, and to the left is considered upstream and to the right is considered downstream. So everything is moving left to right. So everything downstream or to the right of this loft would not work if I had it disabled. And there's different reasons that you would use these at different times. Just note also that when something is disabled, the entire kind of parameter or component is grayed out. So when we unpreview it, the center stays black, but the outside goes a little bit darker. But when it's previewed, when it's all on, it's all light gray except for the center. And when we disable it, the whole thing goes gray. So just keep those in mind as you're working, and it'll be a little bit more clear kind of what those things mean. Lastly, red in Grasshopper means you've got a problem. Red means that there's a warning of sorts. So if I right-click on this center, or if I right-click on the different kind of inputs and outputs of this, eventually I'll find one that has a runtime error or this red X in it, and it'll be the thing that's telling me what's causing the error. So if I hover over this, it'll tell me that data conversion failed from curve to loft options. So what that means is that this kind of input is asking for options for the loft. So do I want it to be loose? Do I want it to be tight? Do I want it to be straight sections? Do I want it to be developable? All of those same options that you have when you are creating a loft in Rhino. But what I'm feeding into it, or what I'm plugging into it, is a curve, and it's basically saying, hey, I don't want that information in here, get it out. And when I do that, when I disconnect it, so I'm holding down Control and I'm kind of tracing over that line that I want to disconnect, it'll go back to being light gray and everything will be working well again. In Rhino, the colors also mean things, right? So right now, if we were to close Grasshopper, all of these red things would disappear. They're not currently real Rhino geometries. I can't go into Rhino and select this surface. There's nothing here for me to select. I can't select this circle. And so if I want to turn something into a Rhino geometry from Grasshopper, I need to do what's called baking it. And the way that I do that is by selecting it in Grasshopper, right-clicking, and clicking on this bake icon, which is down here. When I do that, it's going to pop up a dialog box that tells me where do I want to bake it. I'm going to select layer 1. Let's actually select layer 2, which is a different color. And you can kind of play around with some of these different settings down here. And then I'm going to hide my Grasshopper geometries for a second. We'll talk about that in a minute. If I go into Rhino now, I've got a surface that was drawn or that was built in Grasshopper, but now I've made it into a Rhino geometry. So you can see that it put it on layer 2. If I go back into Grasshopper and turn my geometries back on, I've still got my red surface. So I've got a red surface, and then I've got my Rhino surface that I'm turning on and off over here by the layer. And as we get into more complex definitions, it'll become more clear why that's important. You wouldn't want to have every object on at all times. They're just going to start layering on top of each other, and you're really most interested in typically the end result, not necessarily every single step along the way being its own version of the geometry. So that the red in Rhino is to remind you that that isn't a real thing yet, and so that's why Grasshopper objects turn red in Rhino unless you have them selected and then they're green. So as I mentioned earlier, I'm just going to get rid of this guy. This is the canvas. In it are parameters and components, and those parameters and components together define a definition. A definition is a combination of parameters and components that do something. So you could have a very simple one like this loft. You could have a very complex one that designs an entire building. All that's important at this point is to know that these things are called a definition. So again, parameters are places where you store stuff. They contain data. They have an input side on the left, an output side on the right, and a component name area in the center. So these things are called curve. I can right-click on anything in Grasshopper and change the name of it. So if I don't want this just to be generic curve, if I want to call it top curve, I can right-click on it and up here in the name box, type that in, hit enter, and you can see that the name of the parameter has updated. I can do the same thing down here, and where it says CRV, I can update that to say bottom curve. And now I know that it's not just two curves, but I know which order they're in and which one is which. You can also select multiple objects and align them, so if I want these two things to be centered on one another, so if I move this guy way over, select these two things, and click on this center black handle, it will align them together. You can also do things like taking three different guys and kind of sorting them out and arranging them like that. And so parameters are things that contain stuff, components are things that contain actions, or they do stuff. The connections between them are called wires, and they're ways of connecting parameters and components and allowing for the information to flow between them. So again, upstream, downstream, flow of information from left to right, and that flow happens along wires. And again, shift makes things makes you be able to connect multiple things into one input. So you can see that there's a little green arrow and a plus sign that comes up when I hold down shift and plug this guy in. And if you hold down control and do the same thing, a little red arrow and a minus sign will pop up, and that'll make it a disconnection. You can also right click on something that you have connected and disconnect or disconnect all. And so if I have two things connected in here, so I'm just holding down shift, I'm going to right click, I can go under disconnect, and because I've named my guys, I'll be able to see which one, I'll be able to see more clearly which one I can disconnect. It also prompts you with the red highlighting when you're hovering over one or the other. It tries to help you figure out what's what. These grips are nodes that indicate the input and output of the parameters and components where the wires can be connected. And if you have under View, Draw Fancy Wires turned on, so if it's slightly grayed out over here on the left, or slightly, I guess you would say highlighted over here on the left. If you have multiple streams of information, so I'm just going to draw very quickly in Rhino a couple of lines to demonstrate what multiple information means. So I've got 4 lines over here, and instead of having two things coming into this, I'm going to change this into curves. And I'm going to get rid of this guy, so I'm going to control exit away. And I'm actually just going to get rid of these two curves that I've been working on as well. In this case, I don't have to always draw one parameter for, it doesn't always have to be a one-to-one relationship between parameters and geometries. You can imagine if I was creating a lofted surface from 20 section curves, cross-section curves, I would have to have 20 of these guys. It would get very confusing very quickly. So what you can do instead of setting one curve at times is set multiple curves. So I'm going to click on this, and then I'm going to go in here and select these guys in order along the same edge. And you'll remember from when we were talking about lofting in the Rhino tutorials that it matters what order you select things in and also at what side you select them. I'm going to drop in a second, let's just drop in a line parameter, I'm gonna draw one last line over here, and I'm gonna set one line for that. I'm gonna pick this guy from one end to the other, which means it's now green, and I'm gonna plug this in to my surface. And actually, I'd want to go back in and select things in different order, so it's basically taking that. I've picked the wrong order, so it's going from the first one that I clicked on to the second one, third one, fourth one, and then it's adding at the end this guy that I moved over here. So I'm just going to move it over for now, for this way. Get rid of this. Okay, so the reason I'm doing that is to indicate the difference between the curves, which have 4 objects in it, and the line parameter, which has 1. So you can see that the line of the curves, because I have fancy wires on, is double, and it's indicating that I have multiple streams of information moving across. And so again, it's kind of a visual cue that's trying to help you understand what's going on in terms of where information is coming from, what types of information are flowing, and to what place. So orange wires mean no data is flowing from left to right. If there's a single stroke like this, it means one piece of data is flowing. If it's a double stroke like this, it means a list of data or multiple pieces of data are flowing. And if there's a dashed line, which we don't see up here at the moment, there's a hierarchical data structure that's flowing from left to right. So it indicates different kind of levels and complexities of information. One last thing in here is that if you select multiple objects, if this is going to be kind of part of something that I'm designing and I want it to always stay together, I can Control G it. I can do Control G, and it will group these things together. So if I grab one of them and move it around, that purple box that kind of indicates the group is going to move with it. So these guys are going to always stay within this box. And I can grab the purple and move them around together as a group, which is nice, especially when you start getting into more complex things. If you want to be able to move things around, sometimes you're kind of picking 10 or 12 different parameters and components and then having to move them. Whereas if you work in groups, it will kind of cluster important relationships of things together and allow for you to move them together. To get rid of a group, all you do is select the purple, not the components and parameters, but the purple kind of outline, and hit delete.